Hi, in this video, I'm going to show you how to import your laser scans into Leica Cyclone, which is the software that Leica uses for point cloud editing and point cloud configuration, and how our scan basically looks like. I will be using this software only as presentation because this software is licensed and it's not available for free. That is why I'm just going to show you the basic step on how to import your point cloud and export it into another format that Cloud Compare also supports. So let's get started. So as what you can see is we exported our data to a USB stick, and I saved or copied our laser scan to this folder right here, OBIC. And this is what you get from the instrument. You have some folders where there is some data about the images that the laser scanner has done. And what's important is this project file. This project file will be used in Leica Cyclone to open this laser scanning project. And Leica Cyclone will automatically recognize all of the folders, all of the imaging that we did, and all of the scanning, which we can then export to another format in which we'll be using in Cloud Compare. All right, so how to do that? This is like a Cyclone. We work with different folders here. As every software, computer software, it has different tabs: File, Edit, View, Configure, Create, Tools, User Apps, and Help. Okay. What we do is we click the plus button here on Servers, and then find a server to your PC. And I already created a database. So how to create a database is you right-click on your work server or your computer, and you left-click the databases. And then you just add a new database. Because I already have one, I'm just going to reuse my previous database. I'm going to expand the plus sign here. And inside the database, you can add or create a project. Okay, this is what we are interested in, to create a project. We created a project called OBIC. We can create a new one. No worries. Let's create a new one for this exercise, OBIC2. And inside this project, we will import our scan station data. Okay, because we use the instrument like a scan station P20, we have to use this tab, import scan station data. And then we're going to import the scan station project, which is located in our folder called OBIC on our computer that we exported from the USB stick. Okay, so let's find this project file. We don't need to actually go and find it. We can just click on the folder and the software will automatically recognize the project file. Okay, so where this is, in my case, this is located on the C drive inside a folder called Leica. And there is this folder OBIC. And I just click this folder OBIC because the project file is located inside this folder. Okay, as you see here. Okay, it's inside the folder. And I'm just going to click here, press OK. And now, Leica Cyclone will ask us some basic questions. How to import to the point cloud. Okay, so there are some general things that we leave on default. We can, in the pre-registration options, we can already use this option to find black and white targets, which I'm going to leave now. Leave as it is. You can also uncheck it if you want. And you can also use to find pipes automatically and filter points by distance. So our office that we scanned last week was, we don't need actually points that are too far away from the center point where the instrument was standing. So the basic is 100 meters here, okay? But I lowered it to 45 meters or 40 meters. We can lower it also to 35 meters, let's say. And then later we will have less work to do when cleaning our point cloud, okay? And then in the P series tab, we can change the intensity overloaded of points, which we're just going to use the default settings. All right. And this cube images resolution in the general tab asks us to how to process the point clouds, how big cubes to use to import the point clouds, import the elements of the point cloud step by step, and how fast to do that. We're going to use the fast option. If we have a slower PC or not that powerful PC, you can use the balanced one or the safe mode, which does not use that much memory on your PC. Okay, let's use the fast option because my PC has, I think, 16 gigabytes of RAM, so it should work fine. All right, let's click OK. You have requested to find pipes. This will take a large amount of memory. Yes, we continue. And now it's importing your setups and laser scan into your project. And once this has finished, we can view our point cloud. What we have here is a warning from Cyclone, so that Cyclone cannot determine machine load balance. This is just a warning that it's using a lot of memory. Make sure you don't press the X, because then the software crashes and you have to start the process once more. So just ignore this, just minimize it. This import takes somewhere between 1 to 3 minutes. So I'm going to get back once it finishes. Okay, now our point cloud is imported. And as you can see is that the software has automatically also found the targets that we placed out around the kitchen area. So these targets have been found. We used 6 targets, which is correct. And these are the center points of the targets that we scanned. It's not the perfect, but we have to stick with it, okay? You can change the view of those targets, whatever. You can just copy all targets to control space or exit. We're just going to copy the targets and replace the existing ones. You can also skip this step. It's not that important now, because we just want to visualize the point cloud. All right, and this is our project. And inside this project, we have our project from our instrument, which have been imported. And we used 2 stations, I say, okay? First station we used was station 1, and we are going to only use this this station data. Okay. Inside this station folder, you have control space, model space, scans, and images. So the images are the images that you took with the camera. Inside the scans, you have the point cloud. Inside the model space, you have a view of your point cloud. If you want to visualize your point cloud, you double-click your model space, and your point cloud will automatically load up. And this is our result currently, what we have done last week. All right, you can navigate through the point cloud with the mouse. If you press the left mouse button, you can turn the point cloud around and hold it. You can turn the point cloud. If you want to go in and out, zoom in and out into the point cloud, you have to press the middle mouse button and zoom in and out. If you want to go left and right on the point cloud, you press and hold the right mouse button. As you can see, our scanner did a pretty good job, because we managed to detect all the tables here and scan the tables. Also, we scanned the pipes, and currently the visualization that I used on the point cloud is this point intensity visualization, which visualizes the elements scanned based on the reflectance values. Okay, so white surfaces don't reflect that well as, for example, dark surfaces or black surfaces. That's why they are visualized with blue and green colors. And very well reflective surfaces are dark surfaces, like those pipes, and also the kitchen, the freezer or the fridge is also visualized in a red color here. Let me just find it. Okay, let's go back. There it is. It's also marked red. Okay. Anyway, this is our point cloud. And what we will do now is just export this point cloud into Cloud Compare, into a Cloud Compare format. Let's just go back here. Yes, we can also navigate the view. So this is the entire overview of the point cloud that we scanned. And we can turn it around, play with it, visualize it differently, whatever. We can also change the intensity or the color. We can use the grayscale intensity map, then all of our points will be visualized in black and white. We can change it back with here with the coloring. So there are many different options which we can use. But remember, this software is just for it's licensed, so it's not available currently for the students. We're just using it to export the ScanStation project to another format, which is supported by Cloud Compare. And then inside Cloud Compare, we will clean this point cloud and find, for example, the diameter of a table or the radius of a table, export the pipe, and so on. Okay, so how to export a point cloud? Well, the easiest thing to do is go to File, Export, and we have to save it somewhere, right? We will save this in the folder called Export, and we are going to use a well-known file for LiDAR scanning, which is called LAS or LAS file, which was developed by Rapid Lasso. That's a company that was made for LiDAR scans, and it's just very good LiDAR information properties and so on. So we're going to name this scan accordingly, whatever we want. Scan, export, and that's it. I'm going to save this, click Save. And here in export options, we can check what we want to export. We can just leave this on default because I'm interested in point intensities, point colors, and also point normals. So normals are the direction where the point has been reflected to. Okay, and yes, this is it. We just leave everything by default and click export. And now our point cloud will start exporting itself into another format. We can also export the point cloud into different formats like comma separated values, ASCII formats, where each column represents a value. And then we can also read that file in Python and other programming languages and do some processing. Okay, so once the export is complete, it tells you that we exported 9 objects. Okay, we basically exported this entire point cloud into our LAS file. So I'm just going to do another export here. I'm going to export this also in a comma separated file. I'm going to select here a CSV option if it exists. Okay, there's no CSV available. There's XYZ, which is closed. Okay, let's export this. Export scan 2. So this XYZ format is basically a simple text format, which we can open with Node++, and then I'll show you how this looks like in a simple ASCII way. Okay, you're just gonna wait this out. Okay, after our export has finished, we have our XYZ file in the folder, but this file is pretty big. Okay, this is just a file that I stopped at 1% because otherwise it's too big and you cannot open it with a text editor. So just want to get you familiar with how this file looks like. So every XYZ file, as the name tells you, has just 3 columns. It has a X coordinate, a Y coordinate, and a Z coordinate in the local coordinate system, which we used for our laser scanning. And each point that we scanned has a coordinate, which we can use then to rebuild our point cloud inside Python or other programming language if we want to. Okay, but this is not important. The thing that's important is this file, the last file that we're going to use in Cloud Compare. Okay, So this is it. And in the next video, we will talk about how to clean point clouds in Cloud Compare.